let's return to our doctor scenario and see if we can figure out what exactly the probability of having cancer is given a positive test result. So, to summarize up here in this box, this is just the information from the problem. And we want to know what is the probability of cancer given that a test is positive. So, think back to your experience with conditional probability and with these probability tables. Remember, the cells in the middle are the joint probabilities, and the cells on the outside that represent the sum across rows or down columns are the marginal probabilities. So hopefully this makes sense to you. We have test positive, the probability of testing positive, the probability of testing negative overall, and here we have the probability of having cancer and the probability of not having cancer overall in the gray marginal boxes. So we can put it in there like this. This is how we denote the marginals. Probability of C, probability of not C, probability positive, probability negative. Good so far? All right. So here's our joints. Here are our joint probabilities, just like in the previous video, the example with hair color and eye color. Well, here, this is the joint probability of having cancer and testing positive. That sounds like something we're interested in. Here's the joint probability of having cancer and testing negative, not having cancer and testing positive, and not having cancer and testing negative. These are our joints. Great, perfect. So let's look at the information again and take stock of what we have and what we need. We are given the base rate for cancer, the probability of cancer in the population. That's 1%, or 0.01. We are also given that people who have cancer, so given that you have cancer, you have an 80% chance of testing positive, or 80% of people who have cancer will test positive. That's represented by this conditional probability right here. We also have this information. So given that you do not have cancer, the probability of testing positive is 7%. So, oh, bollocks. I bollocksed it up. Okay, sorry about that. So this is now accurate. We have the probability of testing positive given that you do not have cancer is 7%. Great. So this is all the information that we're given. But based on this information, we're also sort of given this stuff. So we know that in our population, you either have cancer or you do not have cancer. If there's a 1% chance that you have cancer, well, there's a 99% chance that you don't, since those two things are mutually exclusive. Likewise, the probability of testing positive given that you have cancer, that's 80%. But given that you have cancer, the probability of testing negative has to be everybody who doesn't test positive. So since those two things, testing positive and testing negative, are mutually exclusive, then same thing, they have to sum up to 100% of the population. Well, 80% plus 20% gets us to 100%. And same thing here, if you do not have cancer, testing positive or testing negative has to sum to 100%. So we just do 1 minus this, 0.07 to get 0.93, 1 minus 0.8 to get 0.2, and 1 minus 0.01 to get 0.99. Excellent. Well, what do we want? What are we looking for in this problem? The probability of cancer given a positive test. So given that we have a positive test, so we're looking in this column, and having cancer, well, we're looking in this cell right here. So it would be this out of the total of all the people who test positive. So the people who have cancer and test positive out of everybody who test positive. We can represent that like this. We want the probability of cancer given a positive test. And we know from both our derivation of Bayes' rule and from just the basic statement of conditional probability that the joint over the marginal is the conditional. So that's just what I said, except here in symbols. We have the probability of this joint over the probability of this marginal. But what are these two things? We need these two guys. We need the joint and we need the marginal. How can we find them based on what we're given? Well, remember this formula. This formula right here tells us that each of these joint probabilities can actually be expressed as a marginal times a conditional. There, we just replaced them all with the marginal times the conditional, the appropriate one. So the probability of having cancer overall times the probability of having cancer given, or testing positive given that you have cancer.